SciCuriousID proudly presents a deep dive into one of nature's most awe-inspiring and terrifying phenomena. Imagine a tornado made entirely of fire that truly looks like something ripped from the pages of an apocalyptic novel. This blazing vortex spirals hundreds of meters into the sky, spinning with the raw, untamed force of a powerful storm and the destructive fury of intense flame. Yet, this terrifying spectacle is not a figment of imagination, it is very real. These are fire tornadoes, also known as fire whirls, and they offer a profound glimpse into the astonishing physics hidden within conditions of extreme heat and dynamic motion.
Behind every question lies discovery. I'm Saluna, and this is SciCurious, where we uncover the science shaping our world.
Historical accounts of fire whirls stretch back more than a century, documenting their devastating power. One of the most tragic instances occurred during the Great Kanto earthquake of 1923 in Japan, where a massive fire whirl formed, tragically claiming the lives of over 38,000 people in a mere matter of minutes. More recently, in regions like California and Australia, fire tornadoes have emerged from massive wildfires, generating hurricane-force winds that spread destruction. This raises a crucial question: how does a simple, contained flame escalate into such a formidable, fiery vortex? To truly grasp the mechanics of fire tornadoes, we must first understand the fundamental principles of heat and motion. When fire burns, it intensely heats the air immediately surrounding it, causing this warmed air to rise rapidly, a process scientifically known as convection. As this heated air ascends, it creates a vacuum, pulling in cooler air from the surrounding environment. If this incoming cooler air encounters uneven winds or varied terrain, it can begin to swirl, initiating a rotational movement that causes the column of hot air to start spinning. Once it begins to spin, the rising air column stretches and narrows into a distinct vortex. This stretching action dramatically increases its rotational speed, much like a figure skater spins faster when they pull their arms inward towards their body, demonstrating the conservation of angular momentum. Within that rapidly spinning vortex, flames, smoke, and ash are powerfully pulled upward, forming a mesmerizing yet dangerous fiery spiral. The temperatures inside can soar to over 1,000 degrees Celsius, making it even hotter than molten lava. In smaller, more controlled fires, you might observe miniature fire whirls, sometimes just a few centimeters wide, forming in campfires or during controlled burns in agricultural fields. These small-scale phenomena offer a safe glimpse into the larger process. However, under extreme conditions, characterized by intense heat and powerful winds, these small whirls can evolve into full-scale fire tornadoes. These colossal structures can reach heights exceeding 1 kilometer and generate winds that surpass 200 kilometers per hour, posing an immense threat. Scientists have meticulously recreated fire whirls in controlled laboratory environments to safely study their complex behavior and properties. In a remarkable discovery in 2016, researchers accidentally stumbled upon a completely new type of fire vortex, which they named the blue whirl. Unlike the familiar, chaotic orange flames we typically associate with fire, this blue whirl burns with remarkable cleanliness and efficiency, emitting a calm, steady blue glow. It forms under precise conditions where fuel and air mix perfectly, resulting in almost no soot production. Some forward-thinking engineers believe that the principles behind blue whirls could inspire the development of significantly cleaner combustion technologies in the future. It's also a fascinating fact that the core of a fire tornado isn't entirely composed of flames. It's predominantly made up of superheated air. The visible fire, with its intense heat and light, actually wraps around this superheated air core, continuously feeding on available oxygen as it spirals powerfully upward, sustaining the vortex's fiery structure. From a purely physics perspective, fire tornadoes represent a captivating fusion of two fundamental forces: thermodynamics, which governs heat and energy, and fluid dynamics, which describes the motion of liquids and gases. They beautifully illustrate how apparent chaos can, in fact, create profound order. Intense heat generates powerful rising motion, and the atmosphere responds by converting that energy into a rotational force. This underlying principle is identical to what drives other natural phenomena such as dust devils, waterspouts, and even massive hurricanes. The key difference, of course, being that this particular vortex burns with destructive intensity. So, the next time you witness footage of a towering, swirling pillar of flame, remember this. It is not the result of magic or some inexplicable madness, but rather physics, at its most spectacular and powerful, demonstrating nature's incredible forces. It is a tornado of fire, born from the perfect, yet terrifying, balance of intense heat, dynamic wind, and precise motion. Are you curious for more scientific insights and natural wonders? Then be sure to subscribe and stay curious with SciCuriousID for our next exploration.
There's always more to discover. I'm Selu, and this has been SciCurious. Stay curious, and I'll see you in the next wonder.